Hello, welcome everybody. My name is Kat Stasińska. I work for AOC Archaeology and I am based in the UK. I would like to tell you about the result of my investigation into certain properties of medieval textiles. In my presentation, Z for warp, S for weft, investigating choices of yarn in English medieval textiles. The first thing, what exactly do we mean by S spun and Z span, or by S twist and Z twist? So, the spinning process occurs when fibers are pulled and twisted together into a thread with a suitable tool, a spindle or a spinning wheel. Spinner could choose the direction of spinning by rotating their tool clockwise or anti-clockwise. This produces two kinds of yarn, with fibers twisted in different directions. Clockwise spinning produces yarn of the so-called type S. Anti-clockwise spinning produces yarn of type Z. Using only Z-spun yarn for weaving was probably common in early Anglo-Saxon England up to about the end of the 7th century. Z-spun yarn was used both for warp and for weft. Fabrics woven like this are called ZZ fabrics. Textiles with Z-spun yarn as warp and S-spun yarn as weft, so-called ZS fabrics, also existed, but they were much less popular. Textiles from cemeteries of the 5th to 7th centuries certainly show, among the tabbies and simple twills, a much higher proportion of ZZ fabrics to ZS, about 85%. In contrast, in the later settlement sites of Gloucester, London and York, ZS spinning is much more common among medium-quality textiles. Even taking into consideration the fact that burial textiles cannot be fully compared to settlement textiles, the change seems to be meaningful. It also seems to be part of the bigger trend, as in Europe at this time, ZS textiles also have been becoming more popular. Transition from ZZ to ZS textiles occurred probably around the end of the 7th and beginning of the 8th century. The change was gradual and started from the broken twills. But by the late Anglo-Saxon and Viking Age, ZS spinning was used for most types of wool textiles. There is no obvious explanation for this change. Literature on the subjects mostly suggests aesthetic reasons. It has been suggested that weaving from Z and S threads produces patterns or enhances weaving patterns. So, for example, diamond or herringbone weaves are much more visible. There is also a possibility that ZS textiles have improved physical properties compared to ZZ textiles. For example, they are better insulators or they are more elastic. In my research, I decided to investigate differences between ZS and ZZ textiles and identify possible reasons for the increased popularity of ZS textiles. For the experiment, I decided to prepare samples, 2 sets, one of ZZ textiles and the second of ZS textiles. Each set consisted of tabby, plain weave fabric, 2x2 twill fabric and diamond twill fabric. Then, with samples ready, I wanted to investigate chosen physical properties and assess their appearance, myself and with the help of other people, not engaged in the project, to collect as many opinions as possible about the appearance of textiles. Then, hopefully, I would be able to form some conclusions about the advantage of ZS textiles over ZZ textiles. I started by choosing the fleece and spinning yarn. I used fleece from the Shetland sheep, which belongs to the medium hairy type, one of the most popular types in Anglo-Saxon England. Due to the time limit, I used the spinning wheel, not the drop spindle. The spinning wheel was implemented much later, but produced threads are virtually the same. I have winded spun yarn into skeins and washed and dried it. Yarn was woven into samples. Again, due to the time limits, the modern vertical loom was used, instead of the horizontal loom. Here is the ready set of samples. On the left we have ZZ Textiles and ZS Textiles on the right. From the top we have samples woven in tabby weave, twill 2x2 weave and the diamond weave. And again, the close-up of the tabby weave, twill 2x2 weave and the diamond weave. The first thing I observed was the fact that ZS textiles were smoother and their surface appeared denser. To my surprise, some weaving patterns were indeed more visible, but not necessarily where I expected them. 2x2 twill was more visible for ZS, but the diamond pattern was much more visible in the case of ZZ textile. To see the diamond pattern for ZS textile, the observer needs to place the sample on the correct angle. I asked my colleagues to assess the appearance of the samples, as I wanted to compare my observation with observations made by others. My colleagues were able to handle samples in person. They observed that ZZ samples seem to be softer and more elastic. Describing ZS textiles, they used words like look more solid, more durable, more expensive, smoother. Eventually, I dyed my samples to see how this will influence their appearance. I used madder, Rubia tinctorum, a dyeing plant well known in Anglo-Saxon England. Here are the dyed samples. Both kinds of samples took the color equally well. ZS samples appear even more smooth than before dyeing. Weaving patterns seem to be more visible in all cases. As mentioned at the beginning, I decided to carry on some tests of the physical properties of samples. There are a lot of ways you can test textiles, but due to the limited time and funds, I decided to conduct just two. One connected with the elasticity, and the second one investigating the insulation properties of the woven samples. I started with the elastic recovery test. The principle of this test is to measure how much the textile is prone to deformation. It is usually conducted by applying some weight and comparing measurements before and after the test. For my test, I used 1 kilogram weight. Each sample was suspended with this weight attached for 1 minute, and I compared the length before and after the test. Here we have the results. The graph presents how much, in percent, the length of samples changed under pressure. What we can say about the result? Surprisingly, it looks like ZS samples are slightly more prone to deformation, but the differences between ZS and ZZ samples are minimal, between 0.5 to 3%. It looks like the factor which influences deformation the most is the type of weave. The diamond weave samples deformed the most, then 2x2 twill, and tabby weave deformation was the smallest. The purpose of the next test was to investigate and compare the insulation properties of ZZ and ZS samples. I sewed the edges of each sample together, forming a small pouch. Inside each sample, I placed a tightly closed plastic bag full of warm water, 55 Celsius degrees. I measured how much temperature changed after 30 minutes and the next after 60 minutes. This is how my setup looked like. Samples were placed at room temperature, about 18 Celsius degrees. Here we have the results. The blue graph shows the result of the first reading and the orange one of the second reading. As you can see, in most cases, readings are essentially the same for all samples. After 30 minutes, the temperature of water in most of the samples dropped to 41 Celsius degrees, and after 60 minutes to 34 Celsius degrees. There was just one exception, which sadly I did not find a good explanation for. In the case of the ZS Tabby woven sample, temperature dropped to 39 Celsius degrees after 30 minutes and to 30 Celsius degrees after 60 minutes. What can I say about the difference between ZZ and ZS textiles after my experiments? The investigation was of course very limited, mostly due to the time scale, so I did not conduct as many tests as I wanted. Results of this which I conducted though show that the physical properties of textiles are mostly connected with their weave, not with the twist of the thread. So, for example, the diamond with ZZ textile is more similar in its physical properties to the diamond with ZS textiles than to the ZZ Tabby. The main difference seems to be indeed the appearance, as mentioned in the literature. As observed by me and my colleagues, ZS textiles seem to be much smoother, which possibly may give the impression of a better quality and maybe even more luxurious kind of textile. This effect is even more visible when textiles are dyed. The pattern of the weave not in every case is more visible. Especially in the diamond weave case, the textile needs to be placed at the correct angle. It is difficult to say if this kind of effect, the pattern not immediately obvious, was desired by Anglo-Saxons or not. ZZ and ZS textiles require further investigation, and I barely scratched the surface of the subject. I am looking forward to any further research. Here is the bibliography. These books cover the subject of textile production in Anglo-Saxon and medieval England, and they also cover the issue of yarn twist. Thank you very much for watching my presentation. I am very much looking forward to your questions.